Hello, ladies and gentlemen. Root Beer here with the second last question on the 2008 Pascal paper. Hopefully you've given this a try. If not, I encourage you to pause the video and try the question out for yourself. You can, of course, download a copy of this contest with the first link in the description. So it's second last question on the contest. That is question 24. And what have we got for question 24? 5 circles are drawn on a piece of paper and connected as shown. Okay, so we've got 1, 2, 3, 4, 5. All right. Each circle must be colored red, blue, or green. So we have some different choices here. 2 circles connected by a straight line may not be colored the same. So if we have blue here, we can't have blue here. We'd have to have red or green. So we have some choices. Okay. How many different ways are there to color the circles? All right, this is sort of a very, very basic enumeration question. And, you know, they run into them all the time on contests. They're great for multiple choice questions. And they're actually pretty interesting as mathematical questions in their own right, not just for contests. But, I mean, I go over them in my first year finite math class. You can get larger, more involved questions about colorings in combinatorics classes. I mean, this is a very stripped down graph theory question. Now, we don't need to know any of that. It's just, you know, fun little extra information as you progress in your math development. You might start hearing about graph theory. You might even already know some of it. So we're going to have to count our possibilities. And, well, there's not really a prescribed way that we have to approach a question like this. I would probably just start... what I would suggest you don't do... Let's first get to that. What I would suggest you don't do is you don't start just drawing out possibilities. Unless you're absolutely stuck, you don't want to just say, okay, well, we'll make this one blue, and this one blue, and this one blue, and then maybe green here. And, well, we haven't used red, so why not use red? Well, there's no reason to use red, actually, for that one. Could have had it green. I mean, you can start making some like this, and that's fine. But if you can try to start counting everything right from the get-go instead of just trying to list out possibilities, that's even better. Now, having said that, if you're sort of stuck on the problem, you don't have a sense as to what's going on, what things might be important, what circles to focus on, or anything like that, then absolutely draw a few out, really try and understand the problem. This is a great strategy on more advanced math questions like 9 and 10 on the Euclid math contest, but that's for grade 12 students. But those are difficult questions, and sometimes it's really hard to know what they're even asking, and so mucking about, drawing a few examples is a good idea for those ones. But with something like this, it's a fairly straightforward question, and we don't want to sort of get stuck in the, well, this one has to be red, this has to be blue. Let's not pin ourselves down with specific colors right now. And another thing I'm probably going to do is I'm going to focus on this circle right here. It sort of sticks out at me. If the question were just with this square right here, well, I'd just, probably pick the top right corner and say, well, there's 3 colors I can have for that. And then move across and say, well, this one is attached to this one. So if I pick blue here, I only can pick red or green here. So there's only 2 choices for color here. And move around that way. And that'd be a fine approach, and I'm sure you can do the question that way. But we don't have a nice, ordinary, symmetric-looking square. We have a square with this little extra bit. It almost looks like a letter Q. Okay. Eraser is being a bit difficult today. And because of that, this one right here, this bottom right corner of the square, it draws my eye, it draws my attention. Now, it might actually be nothing, but I think starting there might be a good idea. As soon as I, pick a color for this one, I say I've got 3 colors here, I can automatically finish off this one right here, this sort of hanging down circle. He's got 2 choices. So we got 3 choices here, 2 choices here for colors. And this one doesn't connect to anything else, so it's done. It's finished. Okay, so if we have, say, blue here, we can only have red or green down here, for example. And so already, like, I haven't finished marking things out yet, but 3 choices and then 2 subsequent choices. There's a nice rule when you're trying to count and you're making choices. You know, if I have 3 choices, and then afterwards with something else, I have 2 choices, the total number of choices is just the product of these two. And if you haven't learned this, it is a useful thing, especially for the occasional counting problem. So right now, I know, while leaving these sort of 3 circles blank, there's 6 ways to fill in these 2 bottom circles. Blue, red, blue, green. Green, red, green, blue. Or red for the bottom right corner of the square, so red, blue, and red, green. That's 6 possibilities. But there's more. There's more choices we could have. Okay. The question is, what else are we going to have? So, I think it might be a good idea. I'm just going to get a little more space here. So there's 3 choices here. I think I'll just label the circles. So I'm starting here, 3 choices, and then subsequently I have 2 choices down here. Now, what are my choices for, say, this one up here, this top right corner? And there's no reason why I'm picking this one as opposed to this bottom left corner, but I am picking them over this top left corner because they're connected to things I've already made a choice about. Okay. So this top right corner here, it's connected. So if the bottom right were blue, then this top right corner could be only 2 choices. There'll only be 2 choices here. It can't share a color with the bottom right corner. Alright. Now, as soon as I make that choice, now you might be tempted to come around here and say, well, that means then there's 2 choices that you can make down here. And that's possible, but that really affects what we're going to have here. Okay? So what I mean by that is, let's say, as I keep mentioning, that this one down here is blue. Okay, I have a choice of red or green for the top right corner. Let's make it red. I have a choice for red or green in the bottom right corner. Okay? If it's also red, then that means I'll have 2 choices, green or blue, for this one up here. But if it's green, then this top one can't be green because it's connected to a green one, and it can't be red because it's connected to a red one, and that forces it to have only 1 choice. So we have to be a little careful. So rather than saying, well, you've got 3 choices down here, 2 choices here, and 2 choices here, you're going to start painting yourself into a corner. You're not going to be talking about, well, there's this many choices here, in general, there's this many choices here. Your choices are now starting to matter. And what happens when you start counting up like that, you need to break it down into cases. Okay? So I think we've identified a good case here. So we've got 3 choices, then 2 choices, then 2 choices when we get up there. But then for this bottom left corner, let's break it up into cases. Not we have 2 choices for it. Let's make it, is it the same color as the top right corner or not? And so we'll break it up into cases. And when you say something like, is it this or this? My choices are this or this. Just like when you say this and this, you multiply how many choices you have. When you have this or this, when you have cases, you add the resulting numbers. Just little finite math tricks you can pick up. It's a nice way to connect language of enumeration to actual calculation. So instead, we'll do 2 cases. So we'll have a case where we've got 3 choices here, 2 choices down here, 2 choices here, and I'll say top right equals bottom left. So they will have the same color choice. I'll actually make this a little bigger because I don't think my numbers can be seen. Well, now the eraser's behaving properly. All right. But if I'm telling you that the top right is equal to the bottom left, then I only have one choice for that bottom left because I've already made the pick for my two choices in the top right. I've got 3 down here and 2 here as usual. But if that's the case, then it's sort of the, well, this one's red and this one's red, and they're the only ones connecting to the top left corner, and so subsequently we get 2 choices. It could be green or blue. Or if both of these are green, it could be blue or red, that sort of a thing. And now we've filled in all the bubbles. Here are our choices: 3 times 2 times 2 times 2, so that's 3 times 8, 24 choices, or 24 possible coloring patterns. Let's get the other possibility, where we know so we still have 2 choices for the top right, but we know for a fact that the bottom left is going to have to be a different one. So the top right is not the same as the bottom left. Now you might think, okay, well, the top right is red or it's green, and so that leaves 2 possibilities for the bottom left. Okay? But remember, it's connected to the very first circle we color, which might be blue, and then this one up here is red, so this is forced to be green. So we still only get 1 choice down here. But now the difference is this top left corner is connected to 2 circles of different colors, and so since circles that are connected can't be the same color, it's forced to be the other color, the third color, blue, which incidentally would have to be the color we chose here. So we only get 1 choice here. But we still get the 3 choices for that first circle, 2 for this circle down here, that doesn't really affect anything, and 2 for our choice of top right. And so this becomes 2 times 3 times 2, or 12 choices. And remember what I said, when you have cases, this case or this case, you add things up. So we're going to have 12 plus 24, or 36. And that's all it is. There's 36 different ways to color them out. And being able to reason your way through this not only is an advantage on this question, but will also, if you can master this reasoning skill, will also help you on the Cayley or the Fermat when they start doing more complicated, more intricate, more involved coloring arguments. I'm not saying it's impossible to write out all 36 possibilities and convince yourself that there are only 36 possibilities. No, that happens on things like the Gauss and the Pascal and the Fryer contest, which is the grade 9 written. But our listing skills are not so important to build up, because if somebody comes along and we had a slightly bigger diagram with maybe 8 circles that were all sort of connected to one another in some scheme, it'd be very hard to draw out all 4,000 possible colorings. Okay? But being able to reason your way through this, say, okay, I've got this many choices here, this many choices here, you can actually get through the question a lot faster and with reasoning and actual mathematics. Okay? So 36, and let's see, is that one of the possibilities? It is. Now, it's a little low compared to some of the others, but I'm fairly confident in my answer. So I will say D and move on. But if you're hesitant because you're saying, well, gee, what if it's 60? What if I missed a whole bunch of other cases? Go back in and re-examine your reasoning. Double check, why did we pick the bottom right? Okay, and how did that affect things? And did I really cover all the cases? I'm not saying you have to get it right the first time every time. But if you're worried that your 36 is too low because you see some of the other numbers, just remember that the other numbers can be wrong if you're confident in your answer. But go back and examine your reasoning. And that's something that you can't really do on a list-based question. You can only go back and scratch your head and say, well, which one did I leave off the list? If you don't create lists with any rhyme or reason, you're going to have a bit of trouble. But there we go. Our final answer is D, 36. And we're all set. And we've got 1 question to go. That'll be question number 25. We'll be doing that video shortly. Just like to say for a moment, feel free to like or subscribe just to let me know you're still interested in these contests. Pascal multiple choice math contests, and feel free to subscribe to be kept up to date when I post the videos that you're interested in. But I don't like pushing the channel that much, so I only do it every once in a while. But no matter what, and you don't have to do any of that, but no matter what, I will see you guys for question 25 as we finish this contest up in the next video.